In this example, we are tasked to find the parametric description for the given oriented curve, a directed line segment from blank and blank to another blank and blank. In this case, we are going to find a directed line segment from one point to another, and we're going to choose what 2 points we would like to use for this. Because of that, I'm actually going to demonstrate how this can be done with 2 different examples, because this will go pretty fast. Let's say that I choose from 1, 4, that's my first point, and I am making a segment from 1, 4 to, let's say, 8, 2. Well, what we're going to do to create a line segment in parametric equations. We're going to start by defining where our beginning point is. For x, my beginning point is 1. And then I want to demonstrate how much we change by considering that as a coefficient on our variable t. And to focus on that, I want to see how much am I changing from my first x coordinate to my second x coordinate. From 1 to 8, I am increasing by 7. So I will say plus 7t. I'll do the exact same thing for y. Y starts at 4 is my first y coordinate, and then I'm progressing to 2. That means I am now decreasing from 4 to 2. I am decreasing by 2 to get there. So 4 minus 2 will get me to my second y value. This is all I really need to make my set of equations, which is very similar to point-slope form. However, what I have currently right now is not the final answer, because this would actually create the full line that goes through those 2 points. But we wanted a segment. We just wanted a segment that goes from one point to the next and stops. To do that, we are going to put bounds on t. The bounds we're going to use are going to be the same every time for these cases. We'll use 0 to 1. If you think about what this does when we plug in these values, if we plug in 0 for t, that's just going to get rid of that second term, and we're just going to have x equals 1 and y equals 4. But if you plug in 1 into these equations, you will have x equals 1 plus 7 times 1, which is 8. And you'll have y equals 4 minus 2 times 1, which is 2. So it will have 0 as your beginning point, and 1 will indicate your ending point. But that's all we really need. Those set of equations with the bounds on t. Let's do that for another set, because that goes real fast. Let's say I go from, I'll do 7 and -5. And we will go to -10 and 1. Well, again, for x and y, start off with your beginning point. X is beginning at 7, y is beginning at -5. And then think about how much you are changing to get to the next x and y coordinate. For x, I'm going from 7 down to -10. That means I am decreasing by 17. So minus 17 t. Multiply t by the amount that you're changing by. For the y values, though, I am starting at -5, and I'm going to 1, so I'm increasing. And I would be increasing by 6. So that's plus 6t. I also do need to include the bounds yet again to make sure that this is actually a segment and not a line. But that would be my set of equations here. If you were to plug in 0 into this expression for both t and x and y, you will just get x equals 7 and y equals -5. But if you plug in 1, you will get x equals 7 minus 17, which is -10. And you'll get y is -5 plus 6, which is +1. So you should also be able to check pretty easily by plugging in your bounds on t to make sure that you do get the beginning point and the ending point on this segment.